All right, welcome back, everybody. Now we're going to do the homework assignments for chapter 14, section 5. And let's look at the first one. Turn the light on here. Okay, this first one says find the gradient of the function f of xy equals 9y minus x at the point 2, 8. Then sketch the gradient and the level curve that passes through that point. All right, so let's look what we have here. This is 14.5, question 1. So our function equals 9y minus x at the point 2, 8. So the first thing we have to find is, let's find the del f at the point 2, 8. Remember, that's the partial of f with respect to x, I, and the partial of f with respect to y, j. So we have to find the partial of f with x or partial of y. The first derivative of this function gives us, as a constant disappears, so it's -1. The partial with respect to y, that's a constant disappears. Derivative of y is gone, so it's 9. So those are our first two, -1, 9. All right, now that also helps us to draw the graph because it goes back 1 and up 9. This is down, down. This is almost non-existent. So back 1, up 9, and there we have it. So the answer is B. Question number 2. Find del f of the given point. So question number 2. Given the function f of x, y, z equals x cubed plus y squared minus 2z squared plus z ln x to the point 1, 1, 1. And we're supposed to find del f at the point 1, 1, 1. Remember, the function for del f is the partial of f with respect to x, I, partial of f with respect to y, j, and the partial of f with respect to z, k. So we have to find these three. So the partial of f with respect to x. So the first one becomes 3x squared. That disappears, that disappears. There's ln x. Z is a constant in this case. So the derivative of ln x is 1 over x. So this one is z times 1 over x, or z over x. Then we have to find partial of f with respect to y. That one is just the derivative of that. The rest are constants disappear. Then lastly, with respect to z. That disappears, that disappears. So it becomes negative 4z. The derivative of z is 1, so we just have ln x. Right? Now we got to look at these at 1, 1, 1. At 1, 1, 1. So it's 3 times 1 squared plus 1 over 1. 3 plus 1 is 4. 2 times 1 is 2. Negative 4 times 1 plus ln of 1. ln of 1 is 0. So the answer is negative 4. So our del function at 1, 1, 1 is 4i plus 2j minus 4k. 4, 2, minus 4. Question number 3. Find the derivative of the function at p0 in the direction of a. F of x, y, z, x equals xy plus yz plus zx. Point 0 is 3, negative 3, 1. And the vector a is 6i plus 2j minus 9. We have to find that. So what does all this stuff tell us? Right there I have. The function xy, yz, cx. The point is at 3, negative 3, negative 1. And our vector is 6i plus 2j minus 9k. So what this says, we have to find the first derivative of the function at p in the direction of a. So this is what it's asking us. The derivative of a direction, derivative of f in the direction of a at the point 3, negative 3, negative 1. So let's see what this all talks about. If f is differentiable, in the region containing the point p sub 0, then the derivative of f at p sub 0 in the direction of a, this is the important part, is given by this. The derivative of f over s at the point p sub 0. Or the derivative of f in the direction of a at p sub 0. Or we can just look at the del operator, the del function at the point p sub 0 dot the unit vector. So we'll be using this function. First step, find del f at p sub 0. Del f is partial of f with xi, partial of f y j, partial of f z k. So let's look at our function and derivative of x. Remember, our function is x, y, y, z, z, x. So derivative of x is just y, of x is z. So it's y plus z. The derivative with respect to y is x plus z, and derivative of f with respect to z is y plus x. All right, so we can build our del function now. Partial, this is y plus z I plus this one is x plus z j plus y sub x k. Remember, this is at the point 3, -3, -1. So we start plugging in the values. Y is -3 plus -1. X is 3 plus -1. J plus -3 plus 3. K. -1, -3 plus -1 is -4 I. This is for my del function. 3 minus 1 is 2. 3 minus 3 is 0. All right. We have our del function. Now we have to find u. Remember, u was earlier, we did this, but here we have a. So we have to find the magnitude of a. A was 6 to -9, so 6 squared plus 2 squared plus -9 squared. 36 plus 4 plus 81. 40 plus 8 is 121. The square root of that is 11. So the magnitude of A is 11. So the unit vector u is 6 over 11 I, 2 over 11 j, minus 9 over 11 k. Now we have to find what we're looking for. By using the del f dot u. Del f was negative 4i plus 2 plus 0 dot 6 over 11i 2 over 11j 9 over 11k. Now I would use multiply each of those terms and then add them together. So negative 4 times 6 is negative 24 over 11. 2 times 2 is 4 over 11. 0 minus 9 is 0. So common denominator, so it's negative 24 plus 4 is negative 20 over 11. And that's our answer. Negative 20 over 11. That's the derivative of the function at the point PO in the direction of A. Question 4. Find the derivative of the function at PO in the direction of A. So it's the same thing. But now we have the trig functions. Question 4. Okay, let's see what we have here. The original function f x, y, z is equal to 2e to the power x cosine of yz through the point 0, 0, 0 in the direction of A, which is negative 3i plus 5j plus 2k. All right, so we have to find derivative of f in the direction of A at the point 0, 0, 0. So first off, we have to find del f, which means we have to find the partial of f with respect to x. So the derivative of e to the x is e to the x. So that's just stays the way it is. The partial of f with respect to y. So that's a constant, stays there. The derivative of the inside, derivative of y is z. So we have 2z e to the x times the derivative of cosine, which is negative sine. And then the df dz, practically exactly the same as the other one, except instead of z, it's x out here, or y. 2y e to the power x sine yz. Now, at 0, 0, 0, we get 2e to the 0 cosine of 0. 2 times 1 is 2. Negative 2 times 0 e to the 0 sine of 0 is 0. Same thing with the other one. 2 to the 0 e to the 0 sine of 0 is 0. So our del f function is 2i plus 0j plus 0k, which is just 2i. So del f equals 2i. Second, find u. So we have to find the magnitude of a, which is -3 squared, 5 squared, 2 squared. 9 plus 25 plus 4. 38. So it's the square root of 38. So the magnitude of a is the square root of 38. So u becomes -3 over radical 38i plus 5 over radical 38j plus 2 radical 38k. So now we have u. Step 3. Find the derivative at point P in the direction of A, which is del f dot u. Del f is 2i plus 0j plus 0k dot -3 over radical 38i plus 5 over radical 38j plus 2 radical 38k. Two times -3 is -6 radical 38. We're just dealing with numbers. 0, 0. So we get -6 radical 38. Rationalize the denominator. We get -6 radical 38 over 38. And 2 goes into 6 3 times. 2 goes into 38 19 times. So it's -3 radical 38 over 19. And that's radical 38 over 19. All right. Next page. Question 5. Find the directions in which the function increases and decreases most rapidly at p sub 0. Then find the derivatives of the function in those directions. So 5, the function is equals x over y minus yz through the point p sub 0, -1, 1, 2. Okay, find the direction in which the function. So we have the first step, we have to find u. So in order to find u, we need to have f over the magnitude of f. That's the first thing the question is looking for. So the magnitude of f, well, we can't, we have to parametricize it first. We have to hold up on this. So we do have to find del f. So partial of f, partial of x. There's no x, so it's 1 over y. Partial of f over partial of y is negative x over y squared minus z. And with respect to z, there's no z there, so it's negative y. At the point negative 1, 1, and 2. So this is x, this is y, and that's z. We get 1 over 1, which is 1. Negative of a negative 1 over 1 squared minus 2. So it's a positive 1 over 1, which is negative 1. And then negative 1. So our del f, partial of f with respect to x, I, partial of f with respect to y, j, partial of f with c, k, is equal to 1, negative 1, negative 1. So it's 1, which is just I, negative 1, so it's minus j, minus k. So that's 1, negative 1, negative 1. So that's my del operator, my del function. Now, I could take the magnitude of that. So it's 1 squared plus negative 1 squared, negative 1 squared. 1 plus 1 plus, which is radical 3. So the first question is asking us for u. So it's del f over magnitude of del f, which is 1 over radical 3i minus 1 over radical 3j minus 1 over radical 3k. So those are the first ones. So it was 1 over minus minus 1 over radical 3 minus 1 over radical 3 minus 1 over radical 3. That was the first question. Now, the direction in which the given function f of x decreases most rapidly at that same point is negative y. So all it is just the opposite of all those. So it's positive 1 over radical 3. It's now negative 1 over radical 3. Negative becomes positive, and negative becomes positive. Now we have to find this function. So negative u simply becomes negative 1 over radical 3i plus 1 over radical 3j plus 1 over radical 3k. The next question says the derivative of f in the direction of u at the point -1, 1, 2. Again, that's the del operator dot u. So our del f was I -j -k dot u, which is 1 over radical 3 I plus or minus 1 over radical 3j minus 1 over radical 3k. One times that, so it's 1 over radical 3. Negative times negative is a positive, so it's plus 1 over radical 3. Negative and negative makes it plus 1 over radical 3. Add those all together, we get 3 radical 3. Rationalize to the denominator. 3 radical 3 over 3. It just equals radical 3. So that's the derivative of the function in the direction of u. So it's just radical 3. That's increasing. If it's decreasing, it's just a negative. There's that one. Okay, number 6. I got glare here. Okay, number 6 says, sketch the curve f of x, y equals some constant together with the del f and the tangent line at the given point. Then write the equation of the tangent line, x squared plus y squared equals 7 at the point radical 2, radical 5. Okay, let me write what I have. This is question 6. We have x squared plus y squared equals 7 through the point radical 2, radical 5. So let's describe what's going on with the questions asking. It's saying sketch the curve together with the del f tangent line. All right. So we know what? We know the gradient vector is normal to the level curve. At the point p sub 0, at whatever point we're looking at. That's by definition. The tangent line is tangent to the level curve and normal to the gradient vector. That'll help us when we do our drawing. So the tangent line has to be normal to the gradient vector, which once we find the gradient vector, it's got to be perpendicular. So the gradient vector that we know, that's the del f operator. So the gradient vector of f at some point p sub 0 is the vector found by the partial derivative of f at p0. Or positional derivative, I'm not particle. Positional derivative of f, which is that vector for the at the point x, y. So that's the first thing we have to find. So let's look at this. We have to find the del operator, the del function. So the partial of f with respect to x in our function is 2x. The partial of f with respect to y is 2y, which is x squared plus y squared equals 7. So putting these in there, we get 2xi, 2yj. And our points, x and y, are radical 2 and radical 5. So 2 radical 2i plus 2 radical 5j. So that's to find our del function. The equation of the tangent line at p sub 0 would at radical 2 radical 5 is found by the partial of f, x at x sub 0, y sub 0, x minus x0, plus the partial of y at the point x sub 0, y sub 0, y minus y sub 0 equals 0. Right, so the partial of f in our function is 2x, x minus x sub 0. I'm building this up. The y is 2y, y minus y sub 0. X is this, y is that, so we have 2 radical 2, x minus radical 2, y is radical 5. Oops, because I can see that. Y is radical 5, so it's y minus radical 5 equals 0. Now, what we have to do to find the equation, get rid of the parentheses, keep all the xy to one side, and the constant on the other side. So we have 2 radical 2x minus 2 radical 2 times radical 2 is 2. Radical 2 5 is radical 2 radical 5 y minus 2 radical 5 is 5 equals 0. So 2 radical 2x minus 4, 2 radical 5y minus 10 equals 0. So move these two numbers to the other side. So it becomes 4 plus 10, which is 14. So we have 2 radical 2x plus 2 radical 5y equals 14. And that's our equation of the tangent line. All right. Now, also another thing it tells us is that that's our equation. So 2 radical 2x. So that can't be it. 2 radical 2x, 2 radical 5y. It can't be. It's not negative. It's positive. So it's got to be C. Now, to figure out which graph it is, we look at our partials at the x and y. So this is 2 radical 2, so it's going positive in the x and positive in the y. Only one that does that is A. Right. Number 7. It's the same thing. Sketch the graph of the function equals c together with the del operator and the tangent line at the given point. Then write the equation of the tangent line, xy equals negative 25, all that stuff. Oops. Question number 7. Xy equals negative 25 to 0.5, negative 5. So first off, let's find the del operator. So we have to find del f with respect to x, which is y, and a del f with respect to a partial of f partial y is x. Now, at our point 5, negative 5, y is negative 5. So the partial is negative 5 at our point, and the partial of f is 5. So our del f is equal to f of x negative 5I plus 5j. Set that equal to 0. Because now we have to figure out the we have to get to the equation of the line and we'll find the curve. So we have negative 5I. Well, so we have our partial f partial x at x minus x sub 0 plus partial f partial y at my equals 0. So partial of f partial of x is negative 5. X minus x sub 0 is 5. And our point x sub 0, y sub 0. Plus the partial of f to y is 5. Y minus negative 5 makes it positive 5. Distribute, get rid of the parentheses. So we have negative 5x plus 25 plus 5y plus 25 equals 0. Negative 5x plus 5y equals negative 50. Changes, Let's get rid of the 5s. So divide everybody by 5. We have negative x plus y equals negative 10. It's a linear equation. Move the x over there. So we add x to both sides, and there's our equation of a tangent line. So the equation of the tangent line is x minus 10. Now, our partials, remember the partial of f partial of x was negative 5. So it goes, our graph goes backwards. Partial of f partial of y is 5. So it goes up equal amount. That's the wrong direction. That's the wrong direction. So these can't be correct. This one is not equal direction. This goes twice that far. So it's got to be D. And now the last one, number 8. Assuming that the necessary derivatives of f of x, y are defined, how are d, if, dj, dk related to f sub partial of f of x, partial of y, partial of z? Well, this is the derivative of f in the I direction, derivative of f in the j direction, derivative of f in the k direction. This is the partial of f with respect to x, which is the derivative of f with respect to x, which is the x direction. I is the x direction, so they're the same thing. df, dh represent the rate of change in the same direction as that, respectively, because direction vectors and gradient vectors have the same direction. Okay, and that's that. Okay, df and x are equal to that respectively because u equals I, the direction derivative of p sub 0 at f. Evaluate at that point when u and I direction is f, right? Yes. So respectively, because when u equals I, the directional derivative at the point is f of x. So they're equal. That equals that equals that, and that equals that. So they're equal. Great. That's just by definition. Okay, everybody. Good luck.